So in your packet, we're going to go to page 15. So page 15 of your packet. All right, so I know we technically haven't done 2.3 yet. We're doing that tomorrow, but I wanted to go ahead and talk about a piece of 2.4, which is solving exponential equations. Because typically, when you're solving an exponential equation with unlike basis, which is going to be any type of exponential equation, you have to use logarithms. We're not even going to learn about this tomorrow. But for like bases, we don't even have to touch logs. We can still just solve by manipulating the exponential itself. All right. So this is the technique that does not involve technology. It's actually pretty easy. Okay. Now, this is called the method of common bases. Now, what is a base when we're talking about exponential expressions? So what is considered the base of an exponential? The number connected to the exponent. All right. So typically, if I said 2 cubed, my base is 2. All right. It's the number being raised to the power. The number or value being raised to that power. So when I'm talking about like bases, that means we want to get that big number the same number, which is possible in certain scenarios. So we're going to look at some very, very simple ones. Now, this is why I want you guys to have your power chart out, because it'll help you find those like bases quickly, because you'll be able to see the different bases raised to all the different powers, and you can see where the numbers line up. So what we're going to do is we're first going to rewrite these equations with a common base. So what do I mean by that? Let's look at letter A. If I have 2 to the x power equals 16, I want to make it so that both of these are raised to the same. Both of these are going to be the same number, just raised to different powers. All right? Now, if you think about it, 2 is pretty low, so we can't really manipulate that one. But 16. Can I rewrite 16 in terms of a base of 2? So can I rewrite 16 as 2 raised to some power? Yeah. What is it? 2 to the 4th. That's all I mean by like bases. So I have 2 to the x is equal to 2 to the 4th. That's all I did. I just rewrote 16 using a base of 2. Now, here's the nice thing about common bases. Once you get the common bases, you can essentially mark out the common bases and bring your exponents down. X equals 4. And that's your answer. Because think about it. If I plug in 4 for x here, it's not true that 2 to the 4th power is equal to 16. So if I plug this 4 back in for this x, does it make this statement true? Is 2 to the 4th power equals 16? Mm-hmm. Yeah. So the hardest part is finding those common bases. So guys, clamshell your laptops for me. You don't need them open right now. Let's try another one. Now, these are ones where we only have to change one side to be a like base. All right? And we only got to change one of them to fit the other. So between these two numbers, which one do you think I'm going to change? What number? Which number? 27. What do you think the like base is going to be? So what do you think it's going to be a base of? 3. So we're going to rewrite both of these as a base of 3. Now, since this one's already a base of 3, we can just rewrite it as it is. So 3 raised to what power is equal to 27? 3. So 3 to the third power is equal to 27. Now that the bases are the same, we can say bye-bye to them and bring down our exponents to equal each other. So x is equal to 3. Any questions so far? Pretty easy, right? Now, look at this one. So think carefully about this. We got a fraction, but that doesn't mean we still can't change the base. All right? So, if I want to rewrite this one, what do you think my like base is going to be? So look at your power chart. See where you see 5 and 1/25 in the same column. So if I look at my power chart, I'm looking for where 5 and 1/25 is in the same column. It's in 5. So if you look right here, 5 is here, 1/25 is here. That means the base has to be 5. All right, that's how you can use your power chart to your advantage. You look to see where both numbers are in the same column. That's your like base. So we're going to rewrite these as bases of 5. So I'm going to have 5 to the x is equal to 5 raised to what power is 1/25? -2. They're the same bases now, so these are gone. X equals -2. Now, this last one we can do in 2 different ways. All right. So, if you were looking at this one, what do you think you would use for your base? What number do you think your base would be? Just what do you think? There's actually 3 bases that would work for this. But what do you think? What's the one that comes to mind? You could use 2. I would say more 4. So when it comes to like bases, my rule of thumb is if there is multiple like bases that work, use the bigger one, because then you're dealing with smaller numbers. All right. So I'm going to rewrite this in terms of base of 4. So if I just have a 4 already, what power is it technically raised to? It's raised to the first power. So I'm still going to put that 1 there because it'll come into play with our equation. Now, 16. How can I rewrite 16? 4 squared. Now, that x still exists. So how we deal with that is that we're going to raise 4 squared to the x power. So then we would invoke the power rule, which we talked about on Monday, which just means you take whatever the outside exponent is and multiply it to whatever the inside exponent is. So this would be 4 to the 2x is equal to 4 to the first. Now, since my bases are the same, I can get rid of them and bring down what's in my exponent. So I have 2x is equal to 1. Now, if we were solving for x, is this finished? No, we haven't solved for x just yet because x is not by itself yet. So what would I have to do? Divide both sides by 2. So x equals 1/2. Now, here's the other way I was thinking. So yes, you could have written in terms of base of 2, but you would have had to do like 2 different power rules, so I don't even want to touch that one. But I could also have written this in terms of bases of 16. Why do you think I could use a base of 16? What's the connection between 16 and 4? So we know 4 squared 16, so that means what of 16 equals 4? So the square root of 16 equals 4. Now, if you look at your power chart, it tells you something. Doesn't it say that we can rewrite roots as powers? Because we know that the square root of 16 is equal to 4. So, could we not rewrite the square root of 16 as a power? So look back at your power chart. And I told you to copy everything on it. Specifically right here. What does that say? So the bottom part right here. What does it say? So if we have an nth root, so that could be a square root, a cube root, a fourth root, whatever. How can we rewrite it as a power? It'd be raised to what power? Right in front of you guys. What does it say? How would I read this? This next one, how would I read that? 1 over n. So in other words, you would rewrite it as a fraction. All right, so whatever the root is, so whatever type of root it is, square root, cube root, whatever, that's going to be the number that's in your denominator, and then you're going to put it over 1. All right. So, since this is 16 square root, I can rewrite the square root of 16 as 16 to the 1/2. Because remember, when it comes to a square root, even though there's supposed to be a number right here, the unspoken number there is 2. They just don't put it. It's like how, like, when you have just an x, there's a 1 technically in front of it. So I can raise this to the 1/2 power. Bases are the same now. I can bring everything down, and I would immediately get x is equal to 1/2. So the difference is this one had 2 steps, the other one had 1. But it doesn't matter. All right, if you don't get what I just said about the bases of 16, but you understand the 4, do the 4. All right. If you want to keep it so that fractions are out of it and you don't have to worry about fractions until you're actually physically solving for x, then keep it as numbers out, keep the fractions out of it. It's not a big deal. All right. I'm just showing you guys that there's more than one way to go about these. Like you can use different types of bases depending on what you see. Any questions on these? All right, so basically to sum up what we just did, we would manipulate the right-hand side of the equation so that it shared a common base with the left-hand side of the equation. Now, we can exploit this fact by manipulating both sides so that they have a common base. So sometimes what we've done so far is that we've only changed one base in the equation. So we only changed one side of the equation, whether it was the left or the right. But that's not always the case. Sometimes you have to change both sides. All right, but before we do that, we just need to review this exponent law, which again is the power rule. And again, all the power rule states is that if you have x to the a b power, that is the same thing as x to the a times b. That's all you do. You just take that power on the outside multiply it to the one on the inside. To all bases. So let's look at an easy one. So expression A. We want to make it so essentially the parentheses are gone. So if I distribute that x to the 3, what do I have? 3x. So I have 2 raised to the 3x power. That's it. What about this one? So I distribute the 4x to the 2. So this is the same thing as 3 raised to 2 times 4x, which simplifies to what? 3 raised to the what power? 8x. Does everyone understand what I'm doing with this power rule? It's just multiplication. All right, now, be careful with this next one because it's an expression. So we're not going to break apart this expression. We're going to pretend like there's parentheses around it. So when I multiply these together, it's the same thing as it looking like this. So 5 raised to the negative 1 times 3x minus 7. Which, if you forget the 5 for a second and you just look at this expression, what's like your instinct to do with that expression? Distribute. And that's all you would do. You just distribute that negative 1. So if I distribute the negative 1, I have 5. What's negative 1 times 3x? Negative 3x. Negative 1 times negative 7? Positive 7. So if you have like more than one term being multiplied, just treat it as a distribution problem. Try that last one on your own. Yeah. So try that last one on your own. So you're not doing anything solving wise, you're just enacting the power rule, similar to part C, so I'll leave part C up. I'll take you a couple of seconds. Thumbs up if you're ready. 1 more minute. You're just doing the power rule, you're doing nothing else. It's just multiplying. All right, check your answer. So when I brought this together, I just rewrote this as negative 3 times 1 minus x squared. It's just distributing. So I'll distribute the negative 3 to the 1 and the negative x squared. You should get 4 raised to the negative 3 plus 3x squared. Any questions on the power rule? Because if you don't get it, the next part's going to be hard. So any questions while we're on this? All right. So now let's look at where we have to make a common base on each side. So this part especially is where your power chart is going to come in handy. Because what you're going to be looking for is, you want to look for a column that has both of these big numbers in it. All right, whatever column that shares both those numbers, that's the base you use. All right, so look at your power chart for letter A. Take a minute, don't say anything yet, but see if you can figure out which base we're going to change 8 and 32 to. All right, so look at your power chart. You're looking for a column that has both 8 and 32 in it. And by column, I mean vertical. So you're looking for a column with both 8 and 32 in it. Now, here's what we're going to do. Since your power chart only goes up to 10, we're going to do this based off of fingers. So using a number of fingers, what do you think the base is? So hold up the number of fingers of what you think the new base is going to be. So however many, whatever base it's going to be, that's how many fingers you hold up. So what do you think the new base is going to be? You got 2 fingers up, you are correct. So if I look back at my power chart, 8 and 32 both fall right here in the base of 2 column. So since they fall in that same column, that means they have a like base of 2. So I want to rewrite this so they both have 2. Now, I want to bring the x down so I don't forget about it. But I'm going to put this 2 in parentheses. My rule of thumb is if there's ever an exponent already there, bring it down, but put your new base in parentheses so that you know you're going to have to do a power rule. All right? Now, 2 raised to the what power is 8? 3. So 2 cubed is 8. So I'm going to put a 3 right there. 2 raised to what power is 32? 5. So I've now rewritten them as like bases. Now, even though I have the like bases, I still got to do that power rule first to get rid of the parentheses before I can X things out and bring it down. So if I multiply X to 3, what do I get? 3X. So I have 2 raised to the 3X is equal to the 5th. Now I got like bases so I can get rid of them and bring down our exponents. So 3x is equal to 5. So what's the last thing I got to do to solve for x? Divide by 3. So x is equal to 5/3. And we'll just leave it as a fraction. I don't really care about the decimal. So guys, when in doubt, leave it as a fraction. Especially with these. Because you should get fairly nice numbers with these. You shouldn't get any like really weird decimals. Any questions on letter A? Okay, let's try letter B together. So take a minute. Look at the 2 bases. Look at your power chart. See if you can figure out which base is the like base between those 2 numbers. So which base we're going to change to be the common base of those 2 numbers. Take a minute, figure it out. You don't need to solve the problem. I just want you to figure out what the base is. So what would be the new base when I change these numbers? All right. Using fingers, what do you think the base is going to be? Pull up the number of fingers you think the base is going to be. Good job, guys. It is 3. So I want to change them so that both of these are in terms of a base of 3. And since this 9 is already raised to a power, I'm going to put parentheses around the 3 and put 2x plus 1 on the outside. Put the phones up, please. Now, 3 raised to what power is 9? 2. 3 raised to what power is 3? Or, sorry, 3 raised to what power is 27? 3. Now I'm going to do a quick power rule. So I'm going to rewrite this as 3 times 2, or 3 raised to 2 times 2x plus 1 is equal to 3 to the third. And I'm just going to go ahead and distribute it so I don't have to worry about it later. So if I distribute that, it'll be 3 raised to the 4x plus 2 is equal to 3 to the third. I can cancel out the bases. And now when I bring them down, I have a nice little 2-step equation. What's my first step for solving that equation? Subtract the 2. So I got 4x is equal to 1. Then what do? Divide it by 4. So 4x is equal to 1 divided by 4. X is equal to 1/4. Any questions on that one? All right. Now, let's look at this next one together because it's a little bit different. Because if you look, we have an x squared in here. So when we bring it down, it's going to look like a quadratic. All right. Now, between 2 and 64, what do you think the like base is going to be? So what's going to be the like base of 2 and 64? 2. So since we already got a base of 2 for 2, that means I'm just going to bring it down as it is. The only one I got to change is to 64. So 2 raised to what power is 64? To the 6. So cross these out. X squared minus 3 is equal to 6. Now, this is a very simple quadratic because we don't have a b value, meaning it doesn't look like ax squared plus bx plus c. All right, we don't have that bx value. We don't have a singular x. We just have an x squared. All right. So we can solve this function by taking, or equation, sorry. We can solve this equation by taking a square root. So first off, before I can do that, I gotta get the x squared by itself. So what do? Add a 3 to both sides. That goes away. I get x squared is equal to 9. Then what do? Square root both sides. So we know the square root of 9 is 3. However, what you guys learned back in math 2, that you always got to put in front of that number if you take the square root. Plus or minus, good. Because remember, the square root of 9, we don't know for sure whether it's positive 3 or negative 3. Because if you think about it, 3 squared is 9, and negative 3 squared is 9. All right? So to account for both of them, we put that little plus or minus in front of it. So that would be our answer. So it'd be 1. All right, one more and then we're going to call it a day. Let's do one that's a little bit difficult. So on the next page, let's look at letter E. Now, this is where that power chart is going to come in handy. So, with letter E. Now, I know it says 1 over 1296, but remember, if it's a fraction, it's just the negative version of that number. So you're really just looking for where 1296 is. Whatever that exponent is, just make it negative. All right? So, where does 216 and 1296 fall under in your power chart? What base do they both have? They both have what? They both have 6. All right? So, we can change these to be bases of 6. Now, 6 to what power is 216? 6 to the third power is 216. 6 to the what power is 1 over 1296? So in other words, take whatever 6 to the whatever power of 6 it is to equal 1296, just make it negative. Negative 4. Good. Now I can enact power rule. We're doing a 2 power rule here, so I got 6 times 3 to the x minus 2 is equal to 6 times negative 4 times 3x minus 2. Do a quick distribution. So I got 6 is equal to 3x minus 6, which is equal to 6 to the negative 12x plus 8. I can now eliminate. So 3x minus 6 is equal to negative 12x plus 8. What's my first step? I'm going to add the 12x to the other side. You could have subtracted 3x if you wanted to, but I'm going to add the 12 because negative 12 is smaller than 3, just so I'm playing with positive numbers, not negative. So this will be 15x minus 6 is equal to 8. What's my next step? Add the 6 to the other side. So this will be 15x is equal to 14. What's my last step? Divide by 15. Now, since 14 can't go, or 15 can't go into 14, I'm just going to leave it as 14 over 15. And it doesn't simplify any further, so we're just going to leave it as that. So how are you guys feeling about these? They're not terrible. The hardest part really is just finding that common base and then just remembering to do the power rule if you have to. All right. After that, you're basically just solving linear equations. Now, here's my question. I have taught you a strategy before on how to solve any equation. So if you completely forgot how to do this and it was on the test, what would be the best thing you could do? How did I teach you how to solve absolute value equations? Desmos. I taught you using Desmos. It's the same thing for any other equation. So let's say that this was on the test or the EOC, and you took one look at that and you're like, I completely forgot how to do this by hand. Well, all you would do, set the left side of the expression equal to y, set the right side expression equal to y, and then what are you looking for? The point of intersection, and you use the x value at that point. All right. Now, I still want you to practice using this method. All right. But I'm just saying that let's say this is on your test and you completely forget, and it's like a multiple choice question, which you know you get right or wrong. By all means, Desmos for your way out. All right. So that trick that I taught you guys for absolute value equations, the same trick that'll work for exponential. All right, that trick that I taught you will work for any equation. Any questions on that? All right, so here's what we're going to do. You guys need to take out your Chromebook, and you either want to grab a whiteboard or have a sheet of paper out for scratch work. We're going to play a Blook It.